Good morning, dear friends. I am Rajin Linus, Associate Professor of Electrical Engineering Department at Sanjay Godath University, Kolhapur. The last lecture under this power electronic simulation, we have done this constant frequency control of buck converter. Constant frequency in the sense, the switching frequency is constant. So when by making this fixing frequency is constant, how one can vary the duty cycle and how the output voltage will be, all those things we have learned. Already we know that output voltage is equal to duty cycle into that input voltage. So the duty cycle is 1, output voltage will be maximum. Whenever the duty cycle is 0.5, output voltage will be half of the input voltage. Then duty cycle is 0, output voltage will be 0. So in this lecture, as I committed in the last lecture, I am going to explain that variable frequency control, how one can do with the variable frequency, switching frequency control in this buck converter. So before that, I would like to share my MATLAB file so that MATLAB simulation to you so that you can easily understand. Now in this case, I hope it is screen is visible to you. Now let me call this previous simulations what I have done. In this pulses generator, I have given the frequency of 1 by 5000. 1 by 5000 is nothing but 0.0002. 0.0002 is a free period. Then the frequency is 50 hertz. So with pulse width is 50 hertz. So pulse width is 50 hertz in the sense duty cycle is 0.5. Then when the pulse width is 100, that means duty cycle is 1. When the pulse width is 0.25%, then duty cycle is 0.25. I already have explained. So this is what we have done. Then we have gone through the different output voltage. See now, if I make it here, the pulse width is now 20%. Now this only you look at this waveform of the second pulse output waveform. See, this pulse is connected to here pulse waveform. So now if you see here point I have given now the constant, the pulse width percentage is 20%. Automatically you have pulse is only 20% and most of the time it is in off time. So the total time period is nothing but the switching frequency of 55 kilohertz or 0.002. Now if I make this duty cycle as if I make it now 75%, automatically our on time will be more and on time will be more and off time will be less within this switching frequency of time period of 0.0002 or otherwise 5 kilohertz. That's what we have learned. But we are now going to learn about variable frequency control. The variable frequency control, as of my point of view, this pulse generator, it will not help us to do much analysis. Maybe someone, if some experts are there, maybe they know well, but in order to change that, I have done this is the concept of sawtooth waveform. We know the sawtooth waveform is nothing but it will be, let me take the sawtooth waveform in the sense we have this this is the sawtooth wave. This is the sawtooth waveform. Then we will control this DC. We will compare with this and we will write here the algorithm whenever this whenever the DC value is more, it should here in this region DC value is more, that time we will have the output pulse has to come. Then in this region DC value is less, so that output will be 0. Then similarly in this region again output value will be high till this. Like that we have to generate this output pulses. So now whenever this value is coming in this region, this on time will be more and off time will be less. Whenever this is coming to this region, on time will be very less and off time will be more. So this is what I am going to do here. For that, here I have generated sawtooth waveform of assume that now the switching frequency is 0.002, the 5 kilohertz, that means 0.002. So 0.002, then output will be 0 and 1. This I have done by using this repeating sequence block. Then this is a duty cycle. In this duty cycle, if you see here, whenever this value is 1, maximum, this is a constant, this value is 1. Let me run the simulation. You can see here, this is a pulse, second pulse. Remaining waveforms I will let you know. So all the time switch is on. Since all the time switch is on, since DC value is maximum. So now, if I make it 0.5, 50% it will be on, 50% it will be off. So let me run the simulation now. So you can have now 50%. This is the switching time, 0.002. So that switching time, this will be on, and remaining 50% it will be off. Then if you make it as 0.75, and you have that output voltage of maximum on time and minimum off time. Maximum on time and minimum off time. This is what we have done for switching pulses. How that we are relating the duty cycle with this constant block. Then this output is I have given to this MOSFET. The remaining all the circuits are same. So in order to know the variable frequency control, I am taking this switching frequency of this circuit as the reference. So the switching circuit of this reference, I am seeing here the pulse width I have taken in this scope also. This is the reference. So I am not going to open anything in this block. This is already done. We have already I have explained in the last lecture also. Then so now I am taking, there is a pulse as a reference. Then this pulse which is I have given here, it is connected to as a second reference. Then this is the output voltage, output current, and this is the output voltage of this circuit. So how we are going to relate. So now in this case, variable frequency control, how one can do the variable frequency control, either by fixing T on time as constant, vary the T of time, or otherwise fix T of time, vary the T on time, so that we can automatically vary the frequency, switching frequency. So now in the first case, let me take now, I have already done some simulation and I have noted down all the values. So one can, if you try your own, you can easily understand. So now this is the first case. In this case, both the case, this is the switching, for example, switching pulse of, so this is the case of switches. This is a total time now, the switching time. Now I am making here the pulses frequency is switching frequency, switching duty cycle is 50%. Similarly here also I am taking that 0.5 duty cycle. If you run the simulation, you can come to know these two frequencies are same. This is the pulse of the first cycle. This is one cycle. Then second cycle will start. Then third cycle, fourth cycle. Since I have run the simulation for 0.008 seconds, then this is a second circuit pulse. Both are same. On time, off time, all are 50%. So now I want to make it to on time is constant and off time I am increasing. How I will increase? On time is constant and off time is increasing means this is the switching time. Switching time, one cycle of switching. I am going to increase the 2 cycles. That means I am switching time. I am reducing and increasing. I am increasing the time period and reducing the frequency. Increasing the switching time so that reduce the frequency. So now instead of one cycle is this much, I am going to increase this one cycle up to this till 0.04. That means so that switching frequency our case is 1 divided by 0.004. Previously 0.1 divided by 0.002. Now I am going to increasing it, that the switching frequency I am reducing so that time period will be increased. how it will be now. On time has to be constant. On time, this is same, should be this same, but off time I am increasing. So in this case, in this total switching time, now till this total switching time, on time, if you want to make like this, it is around 25 percentage. Remain 25. This is 50 percentage. This is 75 percentage. This is 100 percentage. So what happen? I am going to do here. I am making duty cycle is 0.25 and time period I am increasing. So let me check now. Now I am going to increase this value as duty cycle is, reduce this duty cycle as 0.25 and increase the switching time as point, instead of 0.004, 0.002, I am increasing to 0.004. So if you run, if you check this waveform, see here now, on time is constant. On time is constant, but off time I am increasing. So if on time is constant, off time is increasing, automatically duty cycle, so discontinuity will happen. That is why here one back EMF is there. That means voltage source is there. This voltage source will appear across this output voltage. Output voltage having discontinuity, since it will show the 24 volt. Again, it is increasing to the maximum value. So that discontinuity will happen. So as the off time is more, on time is less, automatically output voltage will reduce. Output voltage will be reduced. Let me run the simulation for 3 seconds. From this, you will come to know that output voltage of this high output voltage will be approximately 164 or 165. This is for constant on time and off time is increasing. Now let me check the same waveform. How now I am going to again run this simulation for 0.008 so that you can easily understand. Now this is on time is constant, off time is more. Now again I am making equal switching of this both the circuit. Switching of both the circuit. Here I am going to take it as 0.002. So now this is same, both the circuits are, both the switchings are same. Now I want to make it switching frequency should be, on time should be increased, off time should be less. On time should be off time should be constant. So this is the off time is constant and on time has to be increased till this. So that off time should be 25 percentage, on time should be 75 percentage. Previously, on time is 25 percentage, off time is 75 percentage. In this case, on time is 75%. On time is 75 percentage and off time is 25 percentage. But I am reducing the switching time and switching frequency and increasing the switching time. So how I can do now? Instead of here first let me take the switching frequency. I am reducing to switching time I am increasing to 0.004 and that the switch on time I am increasing to 0.75. So in this case, what happened? Now if you run the simulation, see here, total switching time is 0.004. It is double divided by double of the previous switching. Double of previous switching. Then on time is more, off time is less. If on time is more and off time is less, here also some discontinuity will happen. But at the same time, if we increase this inductance values also maybe 7, there is a chance of continuous conduction in this waveform. So again we have to increase further, but already in the last lecture also I have explained how to increase the inductance and how the effect will be. So this is, you can learn it from the last video. Now this on time is more, off time is less. If on time is more, off time is less, automatically what happen? Output voltage will increase. So now I am going to run the simulation for 3 seconds. So previously our output voltage will be 164 volt Please now check it now, this output voltage. This output voltage will be 198 something, 197. This is what very clearly we can understand that if off time, if the switching time is increases, that means if the switching frequency is reduces, and if the on time increase, when the on time increase, automatically we can increase the output voltage. At the same time, if the switching frequency is reduces, that means switching time is increases, and if we increase the off time, automatically our output voltage will reduce. So now let me explain how one can do with in this case, we have maintained test on time constant and off time constant. Now let me explain now. Now the frequency I have increases. Frequency increases. Then off time I am reducing. Off time now reducing. How? By maintaining this on. Previously I have increases the off time. In this case now I am going to reduce the off time. For that, what I am going to do here is delta value I am taking it as 0.666 delta duty cycle, and the frequency of this will be, instead of 5 kilohertz, I am taking 1 divided by 6.666 kilowatts, otherwise 6 kilowatts. So I have increasing the switching frequency. Now let me run the simulation for 0.008 seconds. So in this 0.008 seconds, if you run the simulation, we will come to know that here on time is constant. By reducing off time, I increases the switching frequency. On time is constant. By this is our switching time. This is our switching. But previous cases, what happened? On time is increasing, or this is the total time. Previous cases 0.002. Now I am on time is constant, but I am reducing the off time. So if this on time is constant and reducing the off time, automatically again output voltage will be increases. So how this out now? If you run the simulation for 3 seconds, so you will come to know this time also output voltage will be high when compared with this input, compare with the previous cases of 164. See here now also we have more output voltage, more than 200. So this is what, whenever the switching frequency is more and on time is also more, we have good output voltage. Whenever our switching frequency is high and on time is less, we have less output voltage. This is what we have learned today. I hope this lecture will help you to understand the concept, and this will be very clear how the concept of this buck converter control by variable frequency control. Then that buck converter closed loop control I have already explained in this electrical vehicle lecture. I will share the link in this description, so that if you want to learn that, you can learn the same. Moreover, boost converter closed loop also I have already done in this electrical vehicle playlist. Moreover, one more thing, in this below in this lecture, in this description, you can come to know what all the playlists are available. Playlists are modeling of electrical machine, and second one is electrical vehicle, and third one is power system simulation. Playlist already available. So instead of searching the channel and finding which topic, if you go through the playlist, automatically you will come to know the continuous lectures, what are the lectures I have completed. I hope this videos are very helpful to you, and it is very much understandable to you. Those who are interested to learn more thing and understanding the new lectures, new concept, kindly subscribe this channel and press the bell button also. Moreover, shortly I will collect the feedback, how the response and what are all the my audience, what they like and what are all the videos I have to publish. Everything I will send to you shortly. Wish you all the best. Thank you.